So in the earlier lectures, if you remember, we have covered this numerical where we have found out the efficiency of the joint, isn't it? Before that, just let me know if you have understood the concept of this critical section or not. Please unanimously tell me. Okay, fine. ठीक है. So we have seen how to calculate the number of bolts based on only two parameters. Right now, what we have considered is we have found out the strength of the bolt in shearing bearing, and based on that, we have calculated the number of bolts. Then we have seen this efficiency concept, and when efficiency comes into picture, in addition to the strength of the bolt, we also are supposed to check this capacity of the plate also, right? And because of which we have checked the net strength of the plate as well as the total strength of the plate, or the gross strength of the plate. This has to be done in order to calculate the rupture capacity of the plate and bolt capacity as well, because we need to find out the overall efficiency of the joint. And when we say joint, in that case we will have the fasteners, that is the bolts, and the plate as a whole, right? So next, we have also calculated the efficiency for different conditions or different cases. For example, in this case we have uh, studied the simple part, that is when the bolts are connected in a single row and when they are connected in two rows, like this. So naturally, depending on our discussion and depending on the mathematical calculation, what we observe, that this efficiency is less compared to the efficiency observed in the case number 2. It is very much evident. Okay. Now, let us see the next numerical, wherein you will experience not only the uh, failure in what you can say, the shearing and bearing, but we can expect the tension force also. Okay, the tension force which is experienced by the bolts. That's what we are going to see in this particular numerical. So let us see. Determine whether the joint shown is safe or not. This is what you are supposed to identify. Keep in mind one thing, that if the numerical suggests a few parameters or few values, you are supposed to stick to those values only. You are not supposed to assume other parameters. For example, the diameter of the bolt, if the pitch distance, end distance, or edge distance, if they are mentioned in the numerical, you are supposed to maintain those values only. ठीक है? Because few numerical problems may be related to only some calculation purpose, like efficiency or capacity checking, etc. In case of design numerical, then you are free to assume many more parameters. Okay, because design is such a thing that it will depend on your understanding, how much you have understood about the problem, and based on that you will apply your knowledge and try to identify the unknown parameters. Okay, but for few cases wherein everything is given, you are supposed to stick to those values. So what else is given in this numerical? That there are 8 number of bolts whose diameter is 16 mm. Grade of the bolt 4.6. They are used to make connection at section 11. ये specifically mentioned है. Also find the number of 16 mm diameter bolt of same grade 4.6 to connect the double angle section. These double angle sections are 8 mm thick. Thickness of these angle sections, it is 8 mm thick, with the web of the T bracket. So let us understand what exactly is given in this numerical. ठीक है? Uh, can you see this connection with whatever I have drawn over here? In this connection, can you imagine? Just imagine what may be this section, what may be the cross section of this member, which is vertical in nature. क्या हो सकता है ये? This is a side view which I have drawn. Okay. So can you please let me know, as per the information over here, are you able to recognize what may be the cross section of this column? क्या हो सकता है? I section. Great. Why? Because these two vertical lines, है ना? These form the flange. This is another flange. और ये जो बीच का जो पोर्शन है जो डिस्टॉर्टेड है, that is continuation mark. Okay. So if you say that this is the web portion of the I section, that is good. Then I have written over here, this is T bracket. T bracket in the sense the shape of this section is T shaped. Okay, it will be like this. If you see the plan, this is like this. Okay. This is in plan what I am talking about, what I have drawn. Okay. So over here you can see there are again two parallel lines. Can you see these vertical lines? These are nothing but this portion of the T bracket, and this portion which is perpendicular to the direction of this flange, you can say this is web portion, which is nothing but this part. Have you understood this thing? Am I right? Are you able to visualize this thing? This is the web portion. Got it? Next, see what is mentioned, that there are double angle sections. Double angle section rather. Double angle section which is connected to the web of this T bracket. ठीक है? ये देखो ये वाला जो है, and the inclination is mentioned to be 45 degree. It is 45 degree inclination with the horizontal. Double angle section attached at an angle of 45 degree. ठीक है? So double angle का मतलब होता है the angle sections are typically like this. Okay, and for this case there are two angles which are actually attached like this. Sorry, rubber is eraser है. ठीक है, एंगल थोड़ा ये ऐसा सीधा and like this. ठीक है, so this is the double angle section which is actually connected to this part. Okay, and this is the front view, you can say. I am watching this section from here. So what these two angle sections are doing, they are separated with the help of this web portion of the T bracket. Are you getting me? ये कुछ ऐसा होगा, ये आपका वेब प्लेट और ये T section मान के चलो, and this is like this, right? And it is connected with the help of bolts. So we are supposed to identify the number of bolts which are connected to the web portion of the T bracket and the angle section. One thing. Second thing is we are supposed to determine whether this joint at section number 11, which is this section 11, whether it is safe or not. ठीक है? So fine. We have seen such example. If you remember, I had told you one example wherein the joints or the connections will experience not only the shear but tension force also. So this is a typical case. Over here, you can see there is one force which is mentioned. This force is of 200 kilonewton, and this is the axial force, axial tension force. Based on some analysis, this axial force has been identified, right? And it is 200 kilonewton. Then, since this is an axial force, you can anticipate horizontal and vertical component of this force. This the values I have written it over here: cos 45 and sin 45 component, isn't it? So this comes out to be 141.42 kilonewton. So by virtue of this horizontal force, this section, the bolts at this section, it will try to resist this horizontal component. In order to counteract this vertical component of the force, this resistance in this direction will be offered by the number of bolts which are provided over here. If you see, there are eight number of bolts. Okay, so I will let you know how these eight number of bolts are arranged. From here, it is seen that there are only four number of bolts. Okay, but you can understand that these four number of bolts are actually placed at this location. This is the top view I am showing. Okay, and another four number of bolts are actually attached over here. Okay, fine. So before proceeding, I have written few things. TH is the horizontal component which will cause tension in the bolts of section 1-1, as I have discussed. TV is the vertical component which will cause the shear in the bolts in the section. Okay. Now let us try to visualize this complete figure with the help of a three-dimensional figure. Right. So this is the I section flange. Okay, so you can imagine that this is the web portion. I did not draw it, and this is another flange on that other side, like this. Okay, it will be like this. Are you getting me? Is this okay? Have you understood what I have drawn over here? So one more thing will be there, that this is something of this. Okay. So are you getting whatever has been drawn over here? This is an I section. This is one of the flange which is getting connected to this T bracket. Okay. This is a T bracket. There are four bolts over here at this portion, and another four bolts on the other face of the bracket section. Got it? So see these bolts, they won't be visible because there is a partition of this web portion. Are you getting me? Yes or no? Did you get this? Please respond, all of you. Hello. I hope this is understood. Okay. Now you can see these are the two angle sections. Fine. These are the two angle sections which are separated by the web portion of this T bracket. Okay. What we are supposed to do? We are supposed to now, first of all, check whether the eight number of bolts, whatever are provided, they are okay or not. Secondly, we are supposed to identify the number of bolts uh, which may be there on this portion, right? See, whenever we say that the angle section is so much thick, that is represented by the thickness of the angle section. That means this dimension. This is the thickness of the angle section. Okay. So over here, this will be the thickness, and this will be the thickness. Okay. These are the thick. How much thickness is mentioned in this numerical? It is 8 thick. The angle sections are 8 thick. Okay. Now, based on this, two things we are supposed to do. We are supposed to check, and secondly, you are supposed to design, isn't it? Calculation of number of bolts is nothing but the part of design. So, have you understood this figure? First of all, let me know. If you have understood, then only we can proceed. Shall we proceed?
Yes, sir.
ठीक है. Now, in order to check the capacity of this section 1-1, can you please tell me what type of shear and bearing effect will these bolts experience for this connection? Whether it will be single or double.
So this is the final answer without any decision. So now, if you want to do the integration of this, let us say this time here I have to take
Yes.
and number of inputs and we will say
Although I have written something, but you are supposed to imagine whether this connection or whether these bolts in this connection will experience single shear and bearing or double shear and bearing. Why single? So why? That's why. Why it will experience only one shear plane? Why? That is my question. Yes, there are two plates. So as you can see, this is one plate, which is the flange of the T bracket, and there is second plate, which is flange of the I section, isn't it? These two plates are only connected with the help of bolts. Got it? If I come to this web portion, and a web portion of the T bracket, although I have written it double shear and bearing, are you able to visualize and whether this statement is correct? Please tell me.
so 1 is equal to the power 3 plus 6 into 1, so this becomes 7. So please
Yes, let me know.
sorry.
Whether the bolts will experience single shear or double shear in this part, in this complete portion. Double shear. Why? Because see, yes, please let me know. 3 plates. Yes, two are what plates? One. So this is not L, this is angle. Yes, okay, L angle section, and second is the web portion of the T bracket. So, ठीक है. In this connection, in this complete connection, you can see there are two different types of. Uh, I mean, there are bolts which are experiencing two different conditions. That is single shear condition and double shear and bearing condition, isn't it? Connection is one, although, but you can see there are two different types of behavior. Based on this behavior, now we are supposed to apply our calculation part and then solve. So let us first of all see the capacity. So the strength of the bolt in single shear for this case, you write down the formula. everything is required, clause number, page number, etc. You calculate the value. So is this value okay? See, you substitute the necessary values. What will be the FUB value? What should be the FUB value? Ultimate strength of bolt.
Okay. I hope everyone
How
is
much is
the same
FUB value?
answers. Okay.
What is the grade of bolt given?
So now we have to first of all calculate the P1 terms, which is
Grade of bolt is given as 4.6.
P1 terms.
So what will be FUB value?
So as far as P1s are concerned, we are going with 2,
Yes.
4, 6, and 8. So this is nothing but
Yes.
1.3,
400.
5. 20 additional power minute.
400 MPa. Then NN. What will be NN value?
620
If it is in single shear, it will be 1. What will be the value of AN?
plus 1.8 for 1 How much is T1?
What is the value of AN? 0.78 times the area of the bolt. है ना? So pi d square by 4. What is the value of D? In this case, it is I think 16, 16 mm. ठीक है? So you calculate and check whether this value of VDSB is 29 kilonewton or not.
So your natural value is nothing but this values. So this is
ठीक है क्या?
5 divided by. So f of a is basically 7 over here.
Please calculate fast and tell me so that I can proceed. ठीक है, I think this is okay. Value is okay. Hmm? Should I proceed?
So I hope this method is clear to everybody.
Hmm? Now the next step is to identify the strength of the bolt in bearing. So you can make use of the VD PB value.